Open your book to page 528. Today's lesson is to find the value for trigonometric functions for any angle. So if you look in the red box on page 528, again, you have the 6 functions, right? And again, we already covered that. So let's just go over examples how to do this. The key to do all this is make sure you draw your triangle. So draw your triangle and use your Pythagorean Theorem or whatever you need to do to figure out all 3 sides, and then you can use your function to evaluate. So let's go to example 1. It says when the angle theta is in the standard position, its terminal side pass through -3, 4. Find the value of the 6th trigonometric function. Okay, so again, just like what we did before, except now the point is at different quadrant. So you got -3 and 4. So -3, 4. So what you want to do is you want to draw a triangle. You always go straight up and down. Always, never go sideways. Okay, go straight up and down, and then you go to the origin. So that this is called your reference triangle, and this angle over here, this is called your reference angle. Okay. But anyway, so this is -3, 4, and this is 5. The hypotenuse is your radius of the circle, so it's always positive. But this, you have to watch your x and the y. So again, so get 3 sides, and then again after that you just go and do the trigonometric function. So you're going to get sine theta. Okay, sine is vertical, so it'd be 4 over 5. Cosine theta is horizontal, it'd be -3 over 5. And tangent theta is y over x, so it'd be 4 over -3. So I'm going to put a negative on top. Okay. So 4 over -3. So now you do the secondary. So you got the cosecant would be 5 over 4. And the secant would be -5 over 3. And the cotangent would be -3 over 4. And that's it. So again, nothing new. Okay. Okay, now let's go to the example 2. So you're looking for value at 270 degrees. Okay, so 270 degrees is right over here. So in this case, you don't have a triangle. So in this case, if you do the values, okay, so since there's no number, you can put any number, right? Because it's a triangle is a ratio, right? So actually, you can just use 1, okay? So in this case, the x is going to be equal to 0, the y is going to be -1, and radius is equal to 1. Okay, so x equal to 0, y equal to -1, and radius, okay, because again, this is your circle, right? If you draw a circle. So again, so you're going to get the sine function. So sine theta is going to be the vertical, which is -1, over the radius or hypotenuse is 1, so equal to -1. Okay, cosine theta will equal to 0 over 1, so it's equal to 0. Tangent theta, tangent is a slope, right? So slope is y over x. So you got -1 over 0, so that's infinity. You cannot divide by 0, right? So this is undefined. Okay. So now let's go and get the other 3. So sine, you get cosecant. So cosecant is reciprocal. So -1, when you flip it over, it's still equal to -1. Okay, the secant, you flip this over, so it's equal to 1 over 0, right? Again, so this is undefined. Okay, then you have the cotangent. Now this is infinity, so if you flip this over, you get 0 over -1, so you get 0. And if you flip this over, you get 0. So that's how you do it that's how you do the quadrantal angles. Okay. So again, quadrantal angle, remember the hypotenuse or the radius would be 1, and then you can just watch. One of it is going to equal to 0, one is going to be, at 1 or negative 1. So again, bottom line is, go ahead and draw your picture, look at the picture, and figure it out. Okay, let's go to example 3. It says express cosine of 145 degrees as function of an acute angle. So what I wanted you to do is you want to find out this is equal to the function with the acute angle, means between 0 and 90 degrees. So here is your, this is 145. Again, the angle does not be exact. Okay? You can kind of just approximate. So this is 145 degrees. Okay, and so cosine. So in this case, you're looking for cosine, right? Okay, so that's your cosine over here. So it's negative. So you want to bring it to the first quadrant. So what you need to do, you have to find out the alpha over here. Okay, so 180 divided by, subtract 145, you get 35 degrees. So that's your alpha. So when they ask you to find the function of acute angle, means they want you to find the equivalent angle that is in the quadrant 1. So you have to find your alpha, so this is your 35. Okay? And this is your cosine over here. But notice they're opposite. So this is your cosine of 145 degrees. So in this case, they are opposite, so this will equal to negative cosine of 35 degrees because they're opposite. This is negative, this is positive. So you have to put a negative over there. So first you have to find out the equivalent angle, and then you have to figure out if they are opposite, you have to put a negative over here to compensate for it. Okay, now let's continue on. So what if is, let's use the same example. What happens if you're looking for sine? Okay, well if it's a sine function, okay, it's up here, right? So the sine of 145 degrees will equal to sine of, and this one would be over here, right? So it'd be 35 degrees. Then next, so first you have to find the angle, the equivalent angle. Then next you have to see if they're the same or opposite. So they both are the same, so that's it. If they're opposite, you have to put a negative to compensate for it. Okay? So because both of these are positive, right? So they are the same. Okay? Over here they are opposite, so that's why the sign has to be opposite. Okay? So again, first you find the angle, and then next you check the sign. That's how you find the function as an acute angle in quadrant 1. Okay, so let's go to example 4. Example 4a. You're looking for the exact value of sine of 300 degrees. So first, again, you need to get your angle. Now remember, each number on the clock is 30 degrees, right? So this would be 10 hours, right? But you have to start from here. So it's going to be right over here. Okay. So again, you go 10 number this way. So this is 3 o'clock. So if you go 10, same as go 2 this way. So this is going to be at 5 o'clock. Then you draw your reference triangle. Okay. Then you have to find your angle. So this is going to be 60 degrees. So now you have to use your special triangle. So this would be 1, 2, square root of 3, right? So 1, 2, square root of 3. And this is negative, so you have to watch the sign. The hypotenuse is always positive. Okay, so now you have to do sine. So sine is this over here. So this will equal to negative square root of 3 over 2. And that's your answer. Okay, so locate your angle, draw your triangle, label 3 sides, and use your function. Okay, let's go to part B. It's 225 degrees. So it's going to be right over here. So this is 180. So your 225 minus 180 will give you 45 over here. Okay, like this one over here. This is 270. So that's how you get 30 over here, right? 300. Right, so you go 270 and you get another 30. So this would be 60. So that's how you figure out the angles. Okay, so again over here. So this would be -1. So you watch your sign. So -1, and square root of 2. So tangent. So tangent of 225 degrees. 225 is from here to here. So that's your theta. So this is your theta. But when you're using a triangle, you can use alpha to draw the triangle. So the tangent is sine over cosine, or the vertical over horizontal. So you're going to get -1 over -1. So this will equal to 1. Okay, let's go to example 5. So the key is, remember to draw your triangle and get all 3 sides and just look at the triangle and figure out. Okay, so triangle is the most important thing. You got to know how to draw triangles. Okay, page 531. It says find the 5 other trigonometric function of theta if. So this is example 5. So you got cosine theta equal to -3 over 4, and theta is between 180 and 360. So what happened is there are 4 quadrants. So each information will cut down the quadrant in half. So you got 4 quadrants, so use one of them, then you end up with 2 quadrants. Use another one, you will narrow it down to 1 quadrant. It doesn't matter which one you use first. Okay? But I'd like to use this one first. So cosine is horizontal, and it's 3 over 4. So it's -3. So it's going to be over here. So it's -3. So you got 2 possibilities. Right? Cosine is horizontal over hypotenuse. So it's -3 over 4. So you got 2 possibilities. Again, remember, each information, it will narrow down to half, right? So you start with 4 quadrants, use 1 information, you narrow down to these 2. And you have to use the next information to narrow down to 1. So it tells you the one that you want is between 180 and 360. So this one is no good. So this is the one you're looking for. So use your Pythagorean Theorem. So this would be square root of 7. Now don't put 5 over here. Okay? It's not going to be 5. You've got to use your Pythagorean Theorem correctly. So it would be square root of 7, and it's negative. Okay, because this is done. So now, once you get this picture, now you can go and get all your function, right? So sine theta equal to -square root of 7 over 4. Cosine is already given, but I'm going to write it again. So -3 over 4. Tangent theta is this over that, so it'd be square root of 7 over 3, right? Y over x. And the negative cancels out. Then after that, you get cosecant. You just flip this over, so it's going to be -4 square root of 7 over 7. And you flip it over and you multiply by square root of 7 square root of 7. Secant theta, you flip this upside down, you get -4 over 3. Cotangent, you flip this over, so you're going to get 3 square root of 7 over 7. Okay, and that's it. So again, it's not too difficult once you know that to draw triangles and then work it out, and it's not that bad. Okay, so let's go and do some practice.